Hello, I'm Mark Tucker.
Hey, I'm Alan Furstenberg, and we are Two Voice Devs.
Two voice doves. Hey, Ellen, it's good to talk to you another week.
Hey, Mark, it is so good to talk to you. It's always interesting. I just feel like there's just so much going on, and I just want to talk with you about it and get your thoughts on it because, you and I keep coming at this stuff from totally different perspectives, and it's really refreshing.
Yeah, well, there's just lots to learn and lots to do, and there is more than one way to approach different things, and none of these things is going to be a complete solution to something. It's always going to be a part of a solution. You were mentioning though a little earlier that you were doing some research on some open models from Google. What's
Right. So, well, I guess rolling back a little bit, I had the episode a few weeks ago with Roger Kibbe
Yep.
and kind of and a discussion over a year ago with Noble Ackerson about, well, how do we run some of these models? How do we use them?
Yeah.
And at the time, Google's Gemma had just come out, and Roger had said, well, there are a bunch of resources available, and he pointed me at some of them. And since then, I've been trying to wrap my head around more and more of these and just try to understand what are my various options. I kind of came up with, like, so far 5 or 7 different ways that
Oh,
I could run the Gemma model.
okay. That's more than I would have thought. I was thinking
Well,
two or three.
yeah, no, there's a whole bunch. Um, and that's just the pre-trained Gemma model. That's just Gemma out of a box.
Mhm.
You can then, for almost all of these, go and train it with your own data and run it in the same environment still, which I did not play with. That will be another episode, I'm sure. But I kind of wanted to take this moment and just kind of show what some of these look like. And I'm going to acknowledge we're recording this the week before Google Cloud Next. By the time it airs, Google Cloud Next will have been completed. So, for all I know, everything I'm telling you is already obsolete. But I don't think so. I think, if anything, what I'm telling you will all still be true, and then some.
Okay,
Um,
fair enough.
so I want to kind of frame the timing of things to
Yeah,
make
you
it
gotta you
clear.
gotta put a stake in the ground and kind of say this is where things are at this point in time, but it is
Right.
fastly evolving.
So the first thing I want to do is I want to show you what's called the model card for Gemma.
Okay.
And model cards are what the researchers and the companies are using to kind of talk about what the models do and how they were built, and just kind of the pieces for every how where this comes from.
Okay.
So what we have here is the model card for Gemma. And this is in the Google Cloud Vertex AI model garden, which is where all of their model cards for everything that they've done lives. It breaks it down into a nice overview, talks about some use cases, including text summarization, text generation. It also is okay at categorization, although it doesn't quite say that here. It talks a little bit about being able to download the model yourself. And here's where you can get it. So you can deploy it on Kubernetes, and that's one of the ways that you can deploy it, which I won't be discussing. It talks about its data set, how it was trained, talks a little bit about the hardware that was used to do the training, gives some evaluation metrics against pretty standard benchmarks that are out there, discusses the ethics and safety issues surrounding it, including memorization, large-scale harm, content safety, assorted other evaluation results, warns about limitations for some of these, including, my usual factual accuracy. LLMs generate responses based on information they learned from training data sets, but they're not knowledge bases. So LLMs rely on statistical patterns. They don't have common sense.
Yeah.
These are important to call out. Bias, misinformation, release date information about it, links to having it on Kaggle, So if you wanted to access this through Kaggle, there's where you can do so. That's yet another way to access it. Again, not a way that I explored. And the license for it, which I don't know how many people read. But if you go back up to it, there are a couple at the top, there are a couple of interesting bits here. The first is that we have this nice deploy button where we can save it to the model registry and deploy it to an endpoint. So that's interesting. That's, so we can access it directly through Vertex AI at an endpoint for an API. And we'll look at that one in a minute. But even more interesting is this bit over here where we can just try it out directly from the model card.
Oh, interesting. So a little
So it's like a little
interactivity.
sandbox.
Yeah.
So we can ask it a question like, who are you? And it gives us, the nice answer. I'm a large language model. And this is, it can do information retrieval and conversation and code generation and translation. So, this is not terribly sophisticated. It's not in a chat format, even though this particular model supports conversation pretty well, as it tells us, but it's a good, quick, easy way just to kind of start out testing with this model. So that was a nice, interesting thing to see.
Yeah, it's quick. If you're looking at a model and trying to evaluate or understand what it does, or if it's going to fit your purpose, then you can just try it out right there in the playground and start to get a feel for it, and then determine how you want to, either download it or deploy it or host it, or however whatever you're going to do to get access to the model.
Right, and this particular sandbox, it's reasonably quick.
Yeah.
I'm not sure why it thinks a bicycle is more like a car, but okay. Sure. So that's one way to try it out. Now, the other way is to go and deploy it. Now, there's a lot behind this deployment, which was kind of odd and interesting. It was the first time I had played with the model registry, and the first time I had played with this endpoint system. So what it does is when it deploys it, it spins up a Google Compute Engine machine, so a dedicated VM that has a dedicated GPU. So you get to choose the machine type, you get to choose the GPU type. It spins it up, it deploys the model on it, and it makes it available at either a public or a private endpoint. If it's a public endpoint, it's still not exactly open to the world. You still need to access it using authentication. However, hitting that deploy button does two important things.
Okay.
One is it takes a lot of time to actually do the deploy. When I deployed it earlier today, it took over 15 minutes to bring up the machine and bring up the instance. And two, it starts charging real money for it.
Yeah, I was gonna say, how is the hosting situated? Is it kind of like a standard deploy? Okay, I've got a server up and it's available. If I'm using it or not, I'm getting charged for it.
Exactly.
All right, so it's not a serverless.
It's not serverless. This is very much it. You're spinning up your instance at a rate of, so I chose the suggested configuration they recommended for Gemma, and it took about $25 a day to run this model, which seems steep.
Yeah.
But let's take a quick look at what that looks like. When you spin it up, it creates an endpoint for what it calls the online prediction center. So I have my deployment here. It tells me it's active. And I can click on this and get what it says is a sample request, but it's not really. That's kind of a generic looking information. It says you provide instance keys and values and parameter keys and values. And okay, that's not terribly useful, to be perfectly honest. So I had to go digging around for what the format of it needed to be. And I found this collab endpoint that tells me what that instance format needs to look like. And it basically is just an object that has a prompt and some parameters that we completely expect. Max tokens, temperature, top P, top K. Okay, so that seems reasonable. So I wrote, I plunked that into a script. So here we have my trusty shell again.
Okay.
And if we look at this shell script, it's again pretty straightforward. We have a prompt that is just asking, what is a car? It then creates this JSON body that we're going to send to the endpoint. And all of that was from that window that we had just looked at.
Okay.
So if we run this, I've edited out, exactly how long it took, because you don't need to watch, nothing for 5 seconds. But so we get back the predictions along with some additional information. It says it took about 5 seconds to run, which is pretty good.
Yeah.
Not sure it's worth spinning up a machine for $25 a day, but it's pretty good. What I find interesting though is the prediction section includes both the prompt and the output, and that caught me off guard because it wasn't clearly defined anywhere that I could find.
Yeah. So you're gonna have to parse that out. Yeah.
So, and it's not hard to parse out, but it's kind of coming from a world of, GPT-4 and Gemini, which has this nice API, which is clearly defined. This was strange. This was, a lot of digging around to find the API in the first place, and then to getting this reply back that was a little odd.
Yeah, so it's already JSON coming back, but then you have to parse the string to determine what was the prompt and what was the output.
Right. And I then went and started looking for, well, okay, how do I do chats with this? And it says it's tuned for chats if you use the right prompt template for it. And it gave examples of that template. But when I tried using that template, I was getting the same old results. So I don't know if I was doing something wrong or something somewhere was acting very strange, but I don't know what. Regardless, this got me really frustrated because this felt like I'm used to clean, easy to use type stuff. And this clearly was, you're getting down in the dirt for how models themselves work. And that's interesting. And I kind of want to dig in there more at some point. But it feels like it's more raw. It's not really meant for use. And that kind of frustrated me because I'm spinning up a machine, but it doesn't feel like it's ready for use.
Yeah, I could see that. I could see where it seems like it's got some rough edges that need to be worked out.
I feel like, though, it's not that anybody's planning on working them out. It's that, when you get into you get to play with models part, this is what you're playing with. You're getting down in the dirt. But maybe I'm wrong. I haven't played with too many others. So then I started saying, well, okay, Roger had told me about this product called Ollama. And he said, it's really easy. You install it. It's easy to install. You tell it to run a model. You tell it to install and run a model. It loads, installs it, and runs it. I'm like, okay, let's give that a try. So this is the homepage for Ollama. It's there. It's really pretty straightforward. The download button downloads it. You run it. It runs, installs a server on your local machine that just makes things ridiculously easy to do. If you look at the models that are available, they have a bunch that are built in for, that I won't say are built in, that are readily available for download, including Gemma and Llama 2 and Mistral 7B. So there's some stuff there. And then there's just plenty of additional ones, including uncensored versions and various other tuned versions and things that are tuned for different languages. And, so it goes on and on and on. In this case, I was sticking with Gemma because, again, that's kind of what I was out to play with here.
Right. So does the computer that you run it on, does that require a GPU? Because I know there's sometimes where you can train a model on a GPU, but then still just run it on the CPU.
The impression I got was that it doesn't need a GPU. It will use it if it's there. It will identify one if it's there, but it doesn't require one. That said, the machine that I'm running it on is a slightly older machine. It's not last year's MacBook Pro. It's using Intel hardware, not Apple hardware, but it does have a GPU. It has an older GPU in it. And I'll show you in a minute, it works okay, but it's slow. You notice, there's I'm gonna have to speed up the playback during those times because it's well you'll see here. So it's already started. It leaves a server running on my machine, and the server is doing nothing most of the time. But I can just say Ollama run Gemma. And it takes a couple of seconds to load in the model and to start it up. And you can see already why I'm going to be editing some parts of this out so that our audience doesn't fall asleep. But it finally comes up, send a message. So we can say something like, which is more like a car, a truck, or a bicycle. And again, it's going to spin there. And you'll remember before we got back it all at once, now we're kind of getting it back in these halting chunks as we go along. And for some reason in this case it decided to be a lot more terse than the last time we tried this. I guess maybe we could then say why. Because a bicycle has two wheels like a car. All right, this is really
really accurate.
Really showcasing Gemma here. But the interesting bit to this is that Llama also provides an API, and that API has a LangChain JS module for it. So I can write a LangChain script, or I can write a program using LangChain or LangChain JS that does something with Ollama. So I have here a fairly simple test that I actually think is kind of neat. It uses Gemma in two ways. So here we're going to ask it, we're going to say, ask Gemma if a car is more like a bicycle or a truck. So the first thing it does is it sends this whole thing to Gemma and says, break this down into two parts. First, tell me who this is being asked to, and then give me the question that I should be asking them.
Okay.
And you can see this is taking time again, because this time it isn't even streaming the responses. It's waiting for the entire result to come back. So it's come back after quite a few seconds and said, okay, the agent this needs to go to is Gemma, and we're asking it if a car is more like a bicycle or a truck. Sometimes it summarizes that a little bit better. So now it uses the LangChain module to send to Gemma if a car is more like a bicycle or a truck. Sometimes it will say something like, is a car more like a bicycle or a truck? So, sometimes it actually does rewrite that into better English.
Okay.
But today it seems to be cranky on me because, of course, I'm doing a demo.
Of course. So now is it actually sending the query to Gemma to get the response?
So yes, again, it is sent to the Gemma model on Ollama if a car is more like a bicycle or a truck. So we'll see how it replies. The other interesting bit, though, is I could also say, ask Llama if a car is more like a bicycle or a truck. And it would parse out that I'm asking Llama and then whatever the question is. Or you could say something like, I wonder if a car is more like a bicycle or a truck, comma. Ask Gemma that question. And it would extract just what the question part is and who it needs to go to, because that's how these large language models work.
So can Ollama have multiple models running at the same time and then pick which one to call?
So Ollama can have multiple models at the same time. You need to specify in the API which one you want to call at that moment.
Okay.
So in this case, it took 174 seconds total, of which I'll probably edit out a good chunk of that, I hope. So it then breaks down similarities between a car and a bicycle, differences between a car and a bicycle. So that I guess gives you an idea on what it's doing.
Okay.
So I had hoped, when I wrote that, I had hoped to demonstrate it as a good classifier, or not classifier, but as a very simple tool that would let you direct where you want the question to go to. And then your program would get that information and send just the question part to that model.
Okay.
But performance is obviously not its strong point, at least not on my machine. But you can sort of think how you could use, if you were running Ollama on a dedicated machine with a GPU, then it would work reasonably well. So I have one more to demonstrate.
Okay.
And this one is amazing. So I don't know if you have heard of Groq, Groq.
Yeah, that's X's.
No.
Oh,
Grok is the one from X.
All right, it tricked me.
Groq is from a company that is building dedicated hardware to run some of these models. And they're a little bit upset with Elon for using a similarly named
Of course.
thing.
Yeah.
But what Groq lets you do is they've got several models that are available in their public preview. And you can select one of them. And then, like many other things, enter the prompt. So we'll enter our favorite test prompt so far.
Yep.
Yeah. You can see this is using the Gemma 7 model. And we have an answer.
Whoa, that's fast.
That is fast. In fact, end-to-end time, it tells us, is less than a second.
Yeah, so 500 milliseconds, 560 milliseconds. Cool. So
now, I find it interesting that it's telling us that a car is more like a truck than a bicycle, which I think this is the first time we've seen that one.
yeah, I don't know. There's not a lot of consistency here going in.
Yeah, I don't think in this case, though, we have much control over some of the other parameters. But the big thing to note here is less than a second.
Yeah.
For stuff that, you've seen, it has taken anywhere between 3 minutes and 5 or so seconds on some of our other tests.
Yeah.
This is blindingly fast. And it has an API, but I haven't tried it. The API isn't cheap, but I think it's still cheaper than $25 a day. But this is really impressive.
So it's hosting, they're providing the hardware that it's running on, and which have been specially tuned for running these types of models, and then they provide an API to run the models.
Yes.
On that hardware, is that what I'm looking at?
Yes.
Okay.
In fact, it's not just hardware that's been specially tuned. They have built chips that are specially designed to run large language models. Now, it's important, though, to realize these are not chips that are good at tuning large language models, just running them.
I'd be okay with that. If it takes a long time to train or fine tune a model specifically for my purpose, but that happens less frequently.
Right.
And then be able to have a different environment that is optimized for the inference or the query side of things. Yeah, I'm all for that.
I'm all for it. You can easily see that, okay, I will, run on Google Cloud with tensor processing units, some fine tuning, and then ship the model over to there and run it there and get results back that quickly. Or if I don't need it that quickly, run it on, a dedicated server where I'm running Ollama and get it, at a reasonable time. It's
Right.
really just because my machine has, no power to it. At least not when we're talking about this sort of stuff.
Yeah, yeah.
But so it's impressive, and I think you've kind of seen the whole range there of what you have and what you can do with it.
Yeah.
That I had a lot, some frustrations. I really wish the Google Cloud API was a little better documented and a little less raw.
Yeah.
But that's okay. I can deal with the raw. I wish that Ollama ran better on my machine, but I'm pretty sure that's really just my machine. If I was running a machine with a better GPU, it would do a little better.
Yeah.
I think what all of this kind of illustrates, though, is for somebody who's coming from the large language model as a service into this world of doing the fine tuning and spinning up a place to run that fine tuned model and accessing it, and there's a lot to learn and a lot to experiment with. It's not
Yeah.
it's a slightly different world.
Yeah. And there are more moving parts. You have to be worried about more kind of more things to get to a solution that's going to be, one, accomplish the goals, and two, deal with it, deal with the latency issues.
Right. There's lots of other things that you need to deal with, but as Roger and I had discussed, there are lots of good reasons to host things locally or host things in your own environment.
Yeah.
To have that control. So there are trade-offs, and I think it's well, I think it's interesting, and I'm looking forward to seeing where all of these tools evolve.
Yeah, I'm interested to see what's next at Next.
Well, by the time this airs, people will know.
Yeah.
And I am planning a conversation with somebody who will be at Next. So we'll try to break down some of the biggest news items from Next and see what's going on with Gemini and Gemma and all the rest of the gang.
Or if there's anything new, we'll have to see what's going on.
We will have to see what's going on, and you can be sure we will talk about it on Two Voice Devs.
Two Voice Devs. Take care, Alan.
Take care, Mark. Have a great week.
All right.